Alright, for today we're going to be doing 8.3. We're going to finish up this section today after we started it yesterday. To start, we're going to look at some more right triangle trigonometry problems. So basically a review of what we did yesterday. Except for this one, they're asking us to draw our triangle first and then solve for the unknown value. So I'm going to draw in my right triangle. It says sine of 52 equals x over 4. So I'm going to choose this side to be 52 degrees here. And remember our SOHCAHTOA. So we can see that sine is opposite over hypotenuse. So this x needs to be our opposite side. And 4 would be our hypotenuse. So filling in this triangle, we have x. It's going to be our opposite, and our hypotenuse of 4 here. And this would be the right triangle of this equation. And to solve for unknown value, we should multiply both sides by 4. So sine of 52 equals x over 4. We need to multiply by 4 to both sides. These 4s are going to cancel. We have x equals 4 times the sine of 52. We can punch that into our calculators, and we should get x equals 3.15. So again, very similar to what we did yesterday, just drawing our triangles first before we end up solving. Here's our second example. Again, we're going to draw our triangle. Here they say tangent of 61 equals b over 9. So SOHCAHTOA, right up here for a reminder. I'll put this angle here as 61 degrees again. And tangent is opposite over adjacent. So b is going to be our opposite, and 9 will be our adjacent side. So if we look at our triangle, my opposite is going to be b right here, and my adjacent side to this angle is 9. Continuing to solve for this variable, tangent of 61 equals b over 9. We can multiply both sides. So b equals 9 times tangent of 61. So b equals about 16.24. Okay? So again, this is a review of what we did yesterday using sine, cosine, and tangent to solve these triangles. This next one's a little bit different. So again, we're using sine, cosine, and tangent. So cosine is going to be our adjacent over hypotenuse. So if we draw our triangle, and I'm going to choose this angle to be 30 degrees again. My adjacent side is 8z minus 4. Has to be right here. And our hypotenuse of z is right there. And now we want to solve this for z. So we can multiply both sides by z. If I rewrite my equation here, cosine of 30 equals 8z minus 4 over z. So I can multiply both sides by z. These z's are going to cancel. And I'm left with z times the cosine of 30 equals 8z minus 4. Let me scroll down a little bit here. Cosine of 30 is just a decimal. So if we punch that into our calculators, we're going to get 0.866z equals 8z minus 4. We're going to want to subtract 8z here. So we have all our z's on the same side of the equation. These will cancel. So we're left with just negative 4 on this side. Over here, 0.866 minus 8 is negative 7.134z. And if we divide both sides by negative 7.134, we get z to equal about 0.56. Alright? And our last one. So draw a right triangle. They say that the sine inverse of 5 over 9 equals theta. And what we said yesterday is that when we have the inverse, these two values here are side lengths. with sine, this is going to be our opposite side and our hypotenuse. And this is an angle measure. So whenever we use inverses, we're going to get an angle measure from our two side lengths. Okay, so for this one, we're going to draw the triangle. And before I do that, I would like you to pause this video. I want you guys to work on this one on your own. Okay, hopefully that was enough time for a pause. I'm going to draw my triangle in here. I'm going to make this angle be my theta. So sine of 5/9. So my opposite side needs to be 5, and my hypotenuse should be 9. So there's that triangle.